Okay, so example 6 is the example we did not get to yesterday. And there's two parts, and they match up with 38 and 40 in your homework. Okay? So, let's look at 6. Use the Pythagorean theorem and the distance formula to show that the points given determine a right triangle. So, I know one thing I do is I kind of sketch a picture here. I'm a visual person. And so if I sketch a picture, let's see, where is negative 3, 4? And as I said, it's a sketch, right? There's the first point. We have 1, 0, which is over here, right? And where's our other point? 5, 4. So we have this triangle here. And, you know, it's a sketch. We're trying to prove if that's a right triangle. Not, did I draw a right triangle? Is it actually a right triangle? Okay? So, how can we do this? Using the distance formula and Pythagorean theorem.
Get the distance between all of them and have like the A, B, C. So like, I think the hypotenuse is C, and the other two sides should be A and B.
That's what it kind of looks like, right? Okay, so we're going to take the distance formula and we're going to take turns with the pieces. So, for instance, if I use negative 3, 4, and 1, 0, let's use our distance formula and find the distance between those 2 points. So if I find the distance between those 2 points, this is remember, the square root of x2 minus x1, so subtract your x's. I'm going to say 1 minus negative 3 squared plus, now I'm going to subtract my y's, 0 minus 4 squared. And it's the square root of all of that, yes? So now, what do we have here? 1 plus 3 is 4, 4 squared is 16, 0 minus 4 is negative 4, negative 4 squared is 16. We have the square root of 32. I would leave it like that. Because what do we have to do when we put these numbers into the Pythagorean theorem? We're going to have to take these numbers and square them, yes? And it's a lot easier to square this than a decimal. So I would just leave it a square root of 32. Now, pick 2 different pieces. So now what if I pick 1, 0 and 5, 4? Repeat the process. The square root of, subtracting my x's, so 5 minus 1 squared, and subtracting my y's, 4 minus 0 squared. Do the math. We end up with 4 squared and 4 squared. 16 and 16 is going to be square root of 32 again. Curiosity, thoughts on the third side? Am I going to do what I'm going to do, or do you see a shortcut?
It should be already done if they're both of them 32.
You can just plug it in and find out what C is. You should be able to.
Well, but we have to prove. So we have to know our A, B, and C to begin with and prove that they make the Pythagorean theorem true. So I have to know C. And I can use the distance formula because the distance formula is find the distance between the 2 points, right? But here's the point I'm making. Look at this particular triangle. What do you notice between negative 3, 4 and 5, 4? Is there a diagonal there that we need to use a distance formula, or could we... They're on the same level, yes? They have the same y values. Can I just count how far apart they are?
Yeah.
I can't do that with these angled, right? Because I can't count from 1, 0 to 5, 4. That's a diagonal. But this one is a horizontal line. How far apart are negative 3, 4 and 5, 4?
12.
No? 8?
Oh, wait, yeah.
Because they're both at the 4 level. This one's 3 over. And this one is 5 over. So that side has a distance of 8, yes? Or I'll be honest, if you did the formula, you would get the square root of 64 if we use the formula. Okay, that's, I skipped using the formula, but just kind of, it's helpful to look at the actual picture, isn't it? We get so bent up on gotta use my formula, but you only had to use the formula twice there. Now, find a spot you can talk about Pythagorean theorem here. What is our Pythagorean theorem?
A squared plus B squared equals C.
Okay, a squared plus b squared equals c squared. Which are my a and b? It's going to have to be the shorter two, which are the square root of 32's. So square root of 32 squared plus square root of 32 squared is going to equal, technically it's square root of 64 squared, which is, or it's also 8 squared, right? So a squared plus b squared equals c squared. What happens when we square square root? What's the square root of 32 squared?
32.
32, yes, remember that? When you square square root, you just get what's there. So 32 plus 32 equals 64. Is that a true statement?
Yes.
Yeah. 64 equals 64. And so right there, that is my proof. That is my proof it is a right triangle. Okay. So, Pythagorean theorem, distance formula, showing something as right triangle. Okay? That's one option. That's either 38 or 40. The other one, now, I'll be honest, I feel like this one in the notes is a little more difficult, if I recall, than the one in the homework. Because what makes this one difficult? They use lovely variables instead of numbers. But the idea, use the fact that the diagonals of a parallelogram bisect each other. What's it mean to bisect something? Go through it where? In the middle, right? If something bisects it, it cuts it in 2 equal halves. And I started to say halves, I thought I better specify here 2 equal halves. Okay? And so they give us these ordered pairs to make a parallelogram. And we want to prove if this is a parallelogram. And if that's the case, their diagonals bisect each other. How can we find the midpoint of a diagonal? Do we have a formula for midpoint? Yeah, and that's what this is practicing, is using a formula for midpoint. Now, okay, let me sketch a graph. I've got to remember how this works. So, there is a point at AB. So, A is going to tell me to go over A and, I remember how I want to do this, up B. So one of the 4 corners is at A, comma B, right? We're going to come back to this, the A plus C, comma B. I'm going to do that one last. One of the 4 corners is at 0, 0. Piece of cake, got that one right. One of the 4 corners is at C0. So what's C0 going to mean? Right there. Now, the point that I skipped. A plus C, comma B. So that is going the distance of C and adding A to it and then going up B. Because A plus C is the whole distance of C plus that smaller A. And so this is A plus C, comma B. Now, I obviously drew them to make them look like a parallelogram. Just like I can draw that triangle to look like a right triangle, but is it one? And that's what we're going to check. So here's our parallelogram. Key you've got to figure out is your diagonals. So if I'm using my midpoint formula, we want to see this, where's the midpoint of this diagonal, right? So if I first use AB, and I didn't write it in here, but this was C0, yes? So I'm going to use the points A comma B, C comma 0. Remember how to do the midpoint?
Add the X's in it.
Add the X's, divide by 2. Add the Y's, divide by 2. Well, it doesn't clean up very well, but the midpoint of this one is A plus C divided by 2 over, well, I can clean up a teeny bit, B plus 0 is B, B divided by 2. So that's the midpoint of my red diagonal. And then let me find a different color. We want to do the same thing with the other diagonal. Are you seeing where we're going here? And maybe some of you guys got this figured out in homework, so it's not a big deal, but we're going to use A plus C comma B and 0, 0. And we're going to find the midpoint of these two lines, or these 2 points. So add your X's. A plus C plus 0 divided by 2. Add your Y's. B plus 0 divided by 2. Well, clean it up. What little cleanup there is, right? A plus C plus 0. We're just going to have A plus C divided by 2. B plus 0, we're going to have B divided by 2. What's important to notice here? Yeah. These two are equal, yes? So the middle of one diagonal is equal to the middle of the other diagonal. The two middles are equal. What are these diagonals doing? Bisecting each other. Okay. So, is this a parallelogram? Yes. This is a parallelogram. Okay. It is a parallelogram because the diagonals bisect each other. Okay. Okay. I don't need to write the homework in there, right? You guys wrote it in there yesterday? So it was, hopefully you did page 17. You had 2 through 18 evens, 24 through 28 evens, and 38 to 52 evens. Okay, so take a look at 38 and 40 if you have not already. See if you can figure out the information you need for those. We also can talk other homework questions, and we can also, I can put the answer key up and we can get checking done as well. So